Hi, my name is Kyle and I'm participating in Challenge 2017. Today I'll be talking about derivatives. Derivatives represent the slope of a function at a given point. If we were given x cubed minus 3x and we took the first derivative of it, this represents the slope at any given point along this curve. And then if we go down to this one, this is the second derivative of y. So this gives us the concavity. Slope describes the rate of increase or decrease across the graph, while concavity describes the overall characteristic of the curve. Since the concavity is negative for all values less than 0, the curve always curves down for x values less than 0. Since the concavity is positive for all x values greater than 0, the curve curves up for all values after 0. First and second derivatives are the main types of derivatives I'll be focusing on today. The two most popular notations for derivatives are Leibniz and Lagrange notations. I'll also use both of those today. Now that we know what derivatives are, let's talk about how to find them. We can find a derivative using the definition of a derivative shown here. What we would do is we would take the function we already have down here, I just moved it up here, and drop it in where we have all the function symbols. Then we would start to simplify out and cancel everything that we need to. So then you're just left with this, and you would simplify out the h's. They all divide. And so you're left with and when you take h to 0, you're left with the derivative down here. So now let's talk about shortcuts to getting derivatives. Instead of doing that whole long drawn out process, we can use the power rule. The power rule is pretty cool because it saves a lot of time and it's very easy. So as you can see with the derivative of y, we see that this power has been moved basically down here. So you multiply the coefficient in front of x, which is 1, by the power, and then we only subtracted 1 from the power. The same thing happened here, but since the power is 1, multiplying 3 by 1 makes no difference, and then subtracting that 1 by 1 gives us a 0, and x to the 0 is 1, so it gets multiplied in. So we can save a lot of time instead of doing that whole long drawn out definition. We can say y prime. We can find y prime using the power rule. So we would say y prime equals 3 times x to the 3 minus 1 minus 3 times 1 times x to the 1 minus 1. And 1 minus 1 is 0, so we cancel out like I said before, and we're left with 3 squared, or 3 times x squared minus 3. So now that we know how to find a derivative, we can talk about using derivatives. Derivatives are used in a lot of things. When we're finding critical points on a graph, or when we're doing L'Hopital's rule, trying to find limits. It's a very useful skill to have, being able to derive. So let's start with the critical points on a graph. If we take our lovely equation, bring it down one more spot, we're given a graph that looks like this. As you can see, there are points where we have relative maximums and minimums. To find the critical points, all we have to do is take the derivative and set it equal to 0. Once we do this, we can find all the points where the slope is equal to 0 and use those to find the maximum and minimum. So at x plus 1 and x minus 1 are critical points where the slope is 0. At these points, we can find out whether they're maximums or minimums by finding the second derivative at those points. So y double prime, equals positive 6 at x equals 1 and negative 6 at x equals negative 1. Since this one is negative, it is concave down, so it'll create a maximum at x equals 1. Since this one is positive, it will create a minimum just because of the curvature of the graph. Moving on to the L'Hopital application for derivative. So with L'Hopital's, we can do some pretty interesting things like solving problems that don't seem to have a solution. So in this case, we'll do the limit as x goes to 0 of sine x divided by x. If we did this normally, we would just get 0 over 0, which does not equal anything really. It's an indeterminate. So we have to take the derivative of the top and the bottom. As a footnote, sine and cosine create kind of a pattern. So you got sine x and so on. So the important thing here is when we take the derivative of the top, we get cosine x over 1. Because if you use the power rule, it's to the first power, so you multiply it by 1, then you subtract 1 from the exponent, and you're left with x to 0, so that also equals 1. And that gives you an answer of 1 over 1. So, by L'Hopital's rule, this is equal to this. That is just one of the many very interesting things you can do with derivatives. Thank you for your time, and that will be the end of this mini lecture.